Hello and welcome to all students. This is first year BSc class, semester 2nd, paper 1, paper 1, calculus 2nd. This is unit number 2, differentiability. Examples on differentiable. Today we are going to see about examples on differentiable functions. In the previous lecture we solved some examples and we have shown some standard functions are differentiable. So let us take a second standard function and we show that that function is also differentiable on set of real numbers. Okay, so let us take one example. Let f is a function from let f is a function from 0 comma infinity 0 comma infinity to the set of real numbers R, and function defined as f of x is equal to log of x. Okay, f of x is equal to log x. So our question is, show that f is differentiable at every point. Show that f is differentiable on 0 to infinity. Okay, so let us write the answer of this question. Answer: let us write the answer of this question. Let p belongs to open interval 0 comma infinity be any point we show that be any point, and consider limit as x tends to p of f of x minus f of p divided by x minus p. So we check with this limit. Okay, in this limit we make a substitution. It is equal to limit h tends to 0 f of so our substitution is x minus p is equal to h. Therefore x will be p plus h minus f of p and whole divided by h. Okay, so it is equal to limit h tends to 0. Now f of p plus h means log of p plus h minus log p by the definition of function f divided by h. Okay, and by the rule of logarithms it is equal to limit h tends to 0 1 upon h into log of p plus h divided by p. Okay, and it is equal to, so it is equal to limit h tends to 0, limit h tends to 0 log of 1 plus h upon p raised to the power 1 upon h, 1 upon h. Okay, 1 upon h, yes. And it is equal to limit h tends to 0. So we make here what I want is log of 1 plus h upon p, and I want here p upon h. Okay, and divide by p. Okay, divided by p. So that 1 upon p I will put here. See here in the next line, limit h tends to 0 1 upon p into log of 1 plus h upon p raised to the power p upon h, and the value of this limit is it is equal to 1 upon p is constant, and this is nothing but log of e, and finally what we have is 1 upon p. Okay, so this thing exists, and it is equal to f dash of p. Therefore function f of x is equal to log x is differentiable from 0 to infinity. Okay, and the derivative of f is 1 upon x. Okay, so let us go to the next question. Our next question is, write down question is f is function from R to R given by f is function from or we directly write let f from set of real number to the set of real number defined as f of x is equal to mod x. Okay, and discuss the differentiability of f at 0. Discuss the differentiability of f at x is equal to 0. So let us write the answer for this question. Okay. So given function is f of x is equal to mod x on set of real number. Okay. So and we have to check the differentiability at x is equal to 0. Okay, means we have to check whether this limit exists. Okay, so consider limit limit x tends to 0 f of x minus f of 0 whole divided by x minus 0, and that limit is equal to, if this limit exists, then we say that function is continuous, function is differentiable, and if this limit does not exist, then we say that function is not differentiable. Okay, so it is equal to limit as x tends to 0 f of x is mod x minus f of 0 is mod 0 divided by x minus 0 is x. Now it is equal to again limit x tends to 0 mod x upon x. Okay, what is left is mod x upon x. X tends to 0. Now let us take first case. In the first case, as x approaching towards 0, there are two ways to approach towards 0. So let us either from the left hand side or from the right hand side of 0. Therefore, let us take first case. If x is greater than 0 and x approaching towards 0. So in this case, x approaching towards from the right hand side. Okay, so as x greater than 0, therefore value of mod x is x. Okay, as x is greater than 0, therefore consider the limit x tends to 0 mod x upon x is equal to limit x tends to 0. In this case, x is greater than 0. Okay, so mod x is x upon x and it is equal to 1. Okay, now in the second case, we consider x is less than 0 and x approaches to 0. Okay, so as x is less than 0, therefore value of mod x function is minus x as x is less than 0. Now consider the limit x tends to 0 mod x upon x and it is equal to limit x tends to 0 mod x is minus 6 upon x and the value is minus 1. Okay, so what happens is this shows that this shows that the limit f of x minus f of 0 divided by x minus 0 as x tends to 0 does not exist होता है. Therefore function f of x is equal to mod x is not differentiable. it is not differentiable at x is equal to 0. The function is not differentiable at x is equal to 0. So mod x function is not differentiable at x is equal to 0. We'll just take next question. So let us take next question. Next question is f is a function from R to R. F is a function, or we write directly let f from R to R, f from R to R given by f of x is equal to x into sine 1 upon x when x is not equal to 0 and it is equal to 0 when x is equal to 0. Okay, so that f is not differentiable at x is equal to 0. So that f is not differentiable at x is equal to 0. So let us try to write the answer of this question. Okay, so function is f of x is equal to x into sine 1 by x at x not equal to 0, and function has value 0 when x is equal to 0, and we have to show that function is not differentiable at x is equal to 0. So how to show? So we show that limit does not exist. Okay, we show that limit does not exist. So consider limit directly. Consider the limit of f of x minus f of 0 divided by x minus 0 as x tends to 0. We show that this limit does not exist. So how to show? It is equal to limit x tends to 0. X is x into sine 1 upon x minus f of 0 has value 0 divided by x minus 0, and it is equal to limit as x tends to 0, as x tends to 0. So x and x will get cancelled, and what is left is sine of 1 upon x. Okay, and we know that this limit does not exist. This limit does not exist. Therefore f of x given function is not differentiable at x is equal to 0. That was very simple. So there are many problems based on this differentiability of a function. Okay, So this is the end of this lecture. Okay, thank you for paying attention.